Assalamu alaikum wa rahmatullahi wa barakatuh. Hi everyone, I am Mr. Sherif Hamid, Math and Mechanics teacher at STEM Kafr Sheikh High Schools in Egypt. We are going today to solve a very special problem from Pan-African Mathematics Olympiad. For any positive integer n, we define the integer Bn by Bn equals n times n plus 1 times 2n plus 1 times 3n plus 1 and so on till we reach 16n plus 1. Find the greatest common divisor of the integers b1, b2, b3 and so on till we reach b2016. Let's start with our given bn equals n times n plus 1 and so on. We can use the product to rewrite our given. As you can see, bn equals n times product kn plus 1. K starts from 1 to 16, and we use the product only to make the solution easier for us and not using the properties of the product. When we substitute with n equals 1, we will obtain b1 equals 1 times 2 times 3 times 4 and so on till we reach 17, and this will equal 17 factorial, and we can rewrite this number in terms of its prime numbers, so it will be just like that. And of course this method is not applicable to know the higher numbers more than 1. For example, b2 will be more larger and b3 and b4 till we reach b2016. This method is not applicable, and to know the common divisor we must search for another method. So when we start with the two brackets n times n plus 1, we can notice that it is always divisible by 2 for n belongs to positive integer, because if n is even, so it will be divisible by 2, and if n is odd, n plus 1 will be even and it also will be divisible by 2. Similarly, we can use the same idea for n times n plus 1 2 times 2n plus 1. It is always divisible by 3. We can use the induction to make a proof for it, and we can also use another method, which is observing the sequence pattern. For example, if n equals 1, as you can see, when n equals 1, the only number which will be divisible by 3 when we substitute in 2n plus 1 here. And when n equals 2, we will use the middle one, which is 2 plus 1 equals 3. And when n equals 3, we will use the first one, and it is divisible by 3 itself. And the sequence will be repeated frequently. 4 will be the same 1, 5 will be the same 2, 6 will be the same 3, and so on. 7 will be the same 1. So for all n belongs to positive integers, this sequence will be continued. So by this way, we proved that n times n plus 1 times 2n plus 1 is always divisible by 3. And you can notice that these are 3 consecutive numbers or values in our pattern Bn. So the same for B5, the same for n times n plus 1 times 2n plus 1 till we reach 4n plus 1. Of course, these are 5 consecutive values of Bn, so it will be divisible by 5, and the pattern will be repeated each 5 values. The same for 7 and so on. So n times product kn plus 1, k start from 1 to 16, is always divisible by all prime numbers equal or less than 17, such 2, 3, 5, 7, 11, 13, 17. So this is our first part of our solution, that b1, b2, b3 and so on till we reach b2016. All of them will be divisible by 2, 3, 5, 7, 11, 13, 17. So we need to know what are the multiple of the numbers. Is it this value is correct? Do you think that the common divisor, the greatest common divisor is P1? Or it is not necessary to be just like that? We need to know the multiple of each previous prime number in all B2, B3, B16. Let's use a nice trick. 2n plus 1, always odd number for all n belongs to positive integer. Of course, it is, as you can see, 2n is always even, plus 1, so it will be always odd. So B2 is only divisible by 2 only. As you remember, that B2 equals 2 times 3 times 5 times 7 and so on till we reach 33. The only value which is divisible by 2, which is 2. The same for 3n plus 1. Want divisible by 3 for all n belongs to positive integer. So B3 is divisible by 3 only. The same for all numbers from 1 to 17. Generally, Kn is always divisible by K, and the only way to keep it divisible by K is to add multiple of K. And if we add 1, just like our problem, it won't be divisible by K. So Kn plus 1 is always not divisible by K, and as a result, the greatest common divisor for Bn, n times product Kn plus 1 starting from k equal 1 to 16, and when n equals 1, 2, 3, 4 and so on till we reach 2016 will be only one multiple of each prime number. For example, 2 times 3 times 5 times 7 times 11 times 13 times 17, and this is the greatest common divisor of our problem, and this value will equal 500,500, and this is our solution for our problem today. I hope that you understood this problem very well, and see you soon in another problems. Thank you so much.